Let's move on and take a look at compounds with polyatomic ions. Now the word polyatomic, that means we have an ion that's really a combination of several atoms put together, many atoms. Okay, and these combinations are things you just have to get used to looking for. Some of them are very common. So on the back of your periodic table, you're going to notice things that end in ate or end in ite. Okay, that's not all of them, but it's the bulk of them. And if you see that ending ate or ite, you know that this is actually a combination of several atoms, and we just need to know what that combination is. So if we look up on the front of our periodic table, we'd see that lithium is going to have a +1 charge when it makes an ion. It's going to lose 1 electron. Phosphate, that grouping, okay, there's something that it has an identity. There's a certain grouping that makes up phosphate, but before I worry about that, I want to look at its charge. Phosphate is a -3. I know if these two things are going to combine to make a neutral solid, I am going to need 3 lithiums and 1 phosphate. Okay? Now remember, we won't write the ones, but we know they're there. So let's take a look at what this would appear like as a formula. I'm going to write lithium, and there's 3 of them. Li3. Then I'm going to write phosphate, but there's only 1 of them, so I'm not going to write the 1. Now I look to see what the identity of phosphate is. Phosphate is PO4. So the correct formula is Li3PO4. Now there's only 1 phosphate here, so if I wanted to, I don't really need those parentheses. It's still phosphate, there's just 1 of them. The parentheses are only necessary, absolutely necessary, if I have more than 1 of them. So I can put them, or I don't have to. Either way, it's okay. Now let's jump down to magnesium nitrate, see a little bit different. Magnesium is a +2. Nitrate, if we look it up, that whole combination is a -1. All right, for these to make a neutral solid, I'm going to need 2 nitrates this time and only 1 magnesium. So if I write this as a formula, it's going to be 1 magnesium. I don't write the 1. Then it's going to be 2 nitrates. Now I have to write what nitrate actually is. Nitrate is actually NO3. In this case, the parentheses are absolutely necessary to tell me I have 2 of those entire combinations in order to make this compound work. Our last one here, aluminum carbonate. The numbers can get kind of messy, so keep track of them. Aluminum is a +3, carbonate's a -2. Now, I know those don't make 0, they don't cancel each other out, so I'm going to need 2 aluminum ions and 3 carbonates. All right, but be careful, this is where people kind of get messed up. Carbonate itself has a 3 in it. So watch out how you write this. I have 2 aluminums, I have 3 carbonates. Now, the identity of carbonate itself is CO3. Okay? So I actually have 2 3s in a row. CO3 tells me it's carbonate. This 3 down here tells me I have 3 of those carbonate combinations. Okay? And that's the formula for aluminum carbonate. Now let's go back the other way. All you're really going to have to do is start recognizing these. Look at this and go, oh, there's more than 2 elements. There's got to be a better way to name it than to just name all 3 elements that are there. Look for a combination you can find on the back of your periodic table. In this case, NH4 has a special name. That combination is ammonium. Okay? I don't have to worry about the 4. That's just part of what ammonium is. And it's connected to a chlorine, but I'm going to call it chloride because the IDE tells us that when there's a different ending, it tells us that these 2 things are attached. Now you might say, these didn't have IDE. That's because the ATE or the ITE, those endings, already tell us that that combination has been formed. Okay? That is now that kind of an ion and it's stuck with a metal. This one, we start with potassium. Okay, that right there is potassium. This, SO4, we got to recognize is sulfate. And I don't have to change that to IDE because the ATE tells me it's already become an ion and it's going to attach to the metal. Potassium sulfate. This one right here, Ca is calcium. NO3, that right there, I know there's 2 of them, don't worry about that. That is nitrate. That's all we have to say, calcium nitrate, because this is the only way calcium and nitrate are going to come together. There is no way for them to have a different ratio. So there's no need to worry about this 2 or this 2 over here. That's just part of what makes potassium sulfate or calcium nitrate have that formula. Okay, there is no other way to do it. This is the general approach to anything with a polyatomic ion.